Alright, in the previous video we saw what an inverse function is, what it does, how do we make sure that it exists, and we looked at the condition for inverse function existence, which is that it is 1, 1. We also saw three ways of checking if a function is 1, 1: geometric, algebraic, as well as using calculus. So the natural next step is to learn how to find these inverse. Again, there's going to be two methods that we're going to learn. First of all, let's look at it algebraically. Now recall that finding inverse amounts to what you're doing is you're switching the inputs and the output, because the question you're asking is, if I know the output, can I figure out the input? Now algebraically, we know input is represented with x and output with y. Um, it's more like a notation thing, but you can think of it as being alphabetical. X comes first, y comes later, input comes first, output comes afterwards. So let's jump into an example. F of x equals x cubed minus 7, and find f inverse if it exists. First of all, we got to check that it exists. Remember, the condition is that it has to be 1, 1. Now, we already saw in the example in the previous video that x cubed is 1, 1, right? And then you know from your previous classes that you've taken that x cubed minus 7 is just a shifted version of x cubed, right? Um, Perhaps it would be nice to pause the video here and draw a graph of x cubed minus 7 so you remember how the transformations work. You remember, you got to figure out if it's moving up, down, left, or right, right? So anyways, it's also 1, 1. So we're good. Now, to rewrite the function as y equals x cubed minus 7, switching x and y just means we actually literally switch them in the formula or in the equation. So we get x equals y cubed minus 7. And then we solve for y. Add 7. To get rid of the y cubed, you take a cubed root, so you get y is cube root of x plus 7. And you rewrite it in the appropriate notation, saying f inverse x is x plus 7 to the 1/3. Now there's one last step remaining to be done. You've checked if it exists, and then you found it, and then you got to make sure that what you found is correct, right? So that's a verification. To verify, recall the idea behind inverse functions, or the relation between inverse and a function and its inverse. If you do something and then you undo it, you get back to where you started. That's the basic goal. For example, if you have $500 in your account, you add $200 and then you withdraw 200 from an ATM, you get back to 500. So that's how function and inverse function work, meaning performing f and then f inverse is the same as performing f inverse and f, and it should give you back x. So let's verify that. F of x plus 7 to the 1/3 becomes x plus 7 all to the 1/3 cube minus 7. Now by exponent law, the 1/3 times 3 gives you a 1, so you get x plus 7 minus 7, which is x. Let's check the other way around. F inverse of x cubed minus 7 becomes x cubed minus 7 plus 7 to the 1/3, which is x cubed to the 1/3, which is x. So all good here. What you found is correct. So this example illustrates the basic method for finding the inverse function algebraically. Let's look at it graphically now. Now, before we learn how to find it graphically, what does the action of taking an inverse mean, graphically? Let's explore that. What we do know is that finding inverse is switching x and y, right? So what does that mean graphically? And now in this graph here, I'm going to look at the x-axis. So the points 2, 0, 4, 0, or negative 2, 0. When I switch them over, they actually become the y-axis. So the x-axis becomes the y-axis, and vice versa. Everything gets reflected on the line y equals x. Why y equals x? Because that's a line where both values are the same. So if you reflect along that line, what you're doing is you're switching the x and the y values. When you switch the x and the y values, you get the inverse function. In general, if you have a function f of x in the blue function here, you rotate it along the y equals x line, which should be labeled on the purple function here. You get the orange function, which is the inverse function. So it's just a reflection. Here's a question that you can think about. Can you find a function such that it equals its own inverse. So also think about what happens to the graph of that function, or how does that work. Okay, let's look at an example. Let's say you have to sketch the graph of the function square root of -1 minus x and its inverse. So well, the first is to sketch the graph of this function. So again, this is a review for something that you've done before. Ideally, what you want to do is plug in y equals 0 when y is, find out when that happens. That happens when x is -1. So you get a point here. You know the domain, because it's a square root. We're working with real numbers. It's got to be positive inside, so x is less than -1. And the general shape of a root function is that way. And then you draw y equals x, and then use one of these points to find the reflected point. So -1 comma 0 becomes 0 comma -1, and then copy the shape. So the steps would be plot the function, plot y equals x, find some point on f of x like pivot points, x-intercepts, y-intercepts, reflect the graph on the y equals x line using the point as pivot, and then you have your graph for the inverse function. So this concludes the talk about does inverse exist? If it does, how to find it, how to verify that the inverse is an inverse. Um, Next, we're going to go into some calculus of inverse functions.